Position welds are kind of what they sound like, I think, anyway. You're getting a really, really awkward position and then you try and weld. That's what that is.
So get on a yoga pose on one leg, arm wrapped around this pipe, other one here. Yeah, where the position is the challenge.
And you can't see your torch because at some
Oh.
point you're not going to be able to see it's up against a wall. You cannot get your head in there to physically see where you're going with that arc. So that presents its own set of problems. Mirrors can sometimes be used. It's an issue. It's a challenge. And this is, again, where more experience comes in, but also more.
You're going to need to budget that time. Don't be thinking that it's going to be as easy as welding something on the floor when it's up in the air around like that. I can't imagine trying to do something as difficult as welding, not being able to see the torch. The guys that can do that are magicians. That's just crazy. Good morning and welcome to the Management Under Construction podcast. I'm Brad Wyant.
And I'm Dee Davis. And today we're here to talk to you about the very exciting topic of welding and what construction project managers need to know about welding and why. And we're going to specifically focus on metallic pipe welding. Welding seems like it would be really simple, and I feel like it's one of those things that doesn't get the attention that it needs in the industry. It's just putting two pieces of pipe together, right? Like, what's the big deal?
How hard could it be?
How hard could it be? Well, when you're a professional welder, it's got its challenges, as any welder would tell you. I think that most project managers don't think much about it, maybe in relationship to some structural welding, maybe if they've got a lot of fancy welded pipe on their project, they really think about it. But when it comes to general contractors, I think it's really, really important for UGC project managers out there to understand what's really going on with the metallic pipe welding on your job, because it can have a huge impact on your budget if it's not budgeted correctly, but it can also have a huge impact on your project schedule if you are not thoroughly understanding what's involved. So here's the thing. You're not going to be a welding expert when you're done listening to this podcast episode. We're just going to give you enough information to help you understand some of the basic pitfalls that you need to avoid. And then that's enough information for you to go start asking more questions as the situation presents itself. So Brad, how many projects have you had that have involved pipe welding?
All of the projects I've worked on have had pipe welding on them in one way or another. I think that's such a great comment, and that's such a true theme of what this podcast tries to be. The idea that there's so much more to know about pipe welding than most people knew, than I knew. I'm going to learn a ton here, I'm sure, today. Dee knows a ton about this. Knowing what you don't know, knowing enough to know that there's a lot more you don't know, is a great way to avoid big dangers and to ask the right kind of questions that put you in a good position to mitigate risk in a big way. It's like somebody who has never looked at the clearances that are required in bathroom stalls, and then all of a sudden finds when the inspector comes on site, oh, that has to be 60 inches here and 52 inches there, and that grab handle has to be just that long. Oh no, I have to rip this whole bathroom apart. These walls aren't even wide enough to fit that many stalls if that's the requirement. Those kinds of questions, if you don't know to ask them, are going to hurt you. So that's the purpose of this. The best experience I can expand on for the sake of pipe welding was a project that Dee and I worked together on that involved welding some very, very sophisticated pieces of pipe. Stainless steel, Hastelloy, all kinds of other exotic metallic materials. And watching the guys do the work, learning about the machines that they use, learning about the times that they do it by hand and why. I'll never forget somebody who worked on that job with us at the time gave me a piece of pipe that had been welded as a test and said, this took 3 hours. And it was about that big around. For those of you on the listening side of this, not watching, I'm holding something about a quarter around in my hand. And it just blew me away that something could take that long, but also it blew me away how beautiful the weld was and how perfect it was, how perfect it had to be for the environment we were working in, a GMP environment. So I keep that in my little banker's box that I carry from job site to job site or from desk to desk, of like little decorations that you keep on your desk to remind you of what you don't know. So that's certainly a theme I want to keep in mind in this podcast, as well as how beautiful pipe welding can be.
You bring up a very good point, and it's really something that we don't even address in the bulk of this podcast episode is everything that has to happen before you make the weld. There's all kinds of things that have to happen before you can even make a weld. We're not even talking about that stuff. That is a whole nother podcast episode in and of itself. It's not that necessarily going around that tubing took 3 hours. It's everything that led up to finishing that weld took 3 hours. So understanding that labor risk, that's really what we're talking about in this episode. It is important to note that there's lots of different kinds of pipe that can be welded. Even plastics can be welded, as we discussed in season 2, episode 11 with Aaron Luce at Ryan Herco. Today, we are talking about metallic pipe welding specifically and what you need to watch out for on your projects. So to break it up into some bullet points, here's the basic things that you need to have some idea about to help manage your risk. Pipe wall thickness, pipe size, how many joints, how many pipe welds are going to be on your project, how many are going to happen in the fab shop, how many are going to happen in the field. The ones that do happen in the field, where in the field is that going to happen? Where are those field joints going to be? How many different things can go wrong, and how to make sure you get a qualified pipe welder. They always seem simple, and they are simple until things go wrong. And that's often when we really figure out how difficult and how complicated something can be. So the kind of metallic pipe that most people think about when they think of welding is carbon steel piping. That's the pictures with a person with a weld hood on, and they got the leathers, and they're striking an arc, and there's sparks flying everywhere. It's super cool, and I'm not just saying that because I'm married to a welder. It is really cool to watch actual welding, and I have some super cool pictures from some of my projects. They actually call it weld porn. Welders love this stuff, believe me. There's Instagram and TikTok things out there where you can just watch this kind of stuff going on, and it is super fun and cool to watch. So if you really, really like welding, check it out. There's definitely some stuff out there. But for you, the project manager, carbon steel pipe, what you need to know about it is it comes in different wall thicknesses, which is incredibly important to understand. In commercial applications, what you're going to see a lot of is what we call Schedule 40 pipe. It's kind of a standard weight of piping. We see it in general services like heating hot water and chilled water. The exact wall thickness of Schedule 40, before you ask, because I knew you were going to ask this question. I was ready for it, Brad.
Beat me to it. Come on.
I knew you were going to ask me. It depends on the size of piping you were dealing with. So the wall thickness for a 1 inch is different than a 2.5 inch is different than a 4 inch. So if you want to know what that is, you can very easily Google a Schedule 40 pipe chart and just Google it. There's tons of them that'll pop up for free, and you can see what the wall thickness is at any given size. The other thing that you may encounter on some commercial and industrial jobs is what we call Schedule 80 pipe. It's thicker than Schedule 40, but not exactly double, as the name would imply. It's used for higher temperatures, higher pressures, or more corrosive services. So things like steam condensate, and high temperature hot water. The important takeaway here is the lower the number, the thinner the wall thickness. The higher the number, the thicker the wall thickness. So you can get anything from Schedule 10 pipe, which is a thin wall pipe. I believe the thickest I've ever seen is Schedule 160. Very, very, very thick walled pipe. So why does this matter? What do you think, Brad?
Well, I love, first of all, that more in numbers is more in thickness. There's so many things in construction that are counterintuitive. So many labeling systems are like, why is it that way? Gauge is a perfect example of this, in my opinion. Gauge numbers for wires get smaller and smaller, but they get bigger and bigger. Gauge 20 wires thinner than gauge 16 wire. But in this case, Schedule 160 is the thickest, Schedule 10 is the thinnest. That is the way that the people I know that work in pipe welding would have it. They're like, no, simple. Stop. No, don't make it complicated. Not hating on the electricians out there, just making a comment. I think it matters because in a high corrosion environment, especially like steam, not only are you looking at containing pressure, which the pipe has to be strong enough to do, and the thicker the pipe gets, the stronger it is, the more structural integrity it has. It's also that you're counting on the pipe corroding over time, so that thickness is going to go away in rust, and then you still need enough after 25, 30 years of service and however much rust you forecast for there still to be enough pipe wall thickness there to accommodate the pressure of the steam that you're dealing with or whatever other fluid you're working with.
Yeah, steam definitely is, especially if it's not treated properly, can be corrosive. Steam condensate is by its own nature extremely corrosive. We usually will see Schedule 80 in steam condensate. It's not something that you really think about being corrosive, but it is because it's had a lot of the minerals have been flashed out of it. And so it just eats the daylights out of pipe. So treating your steam and things like that will help prolong the life of your pipe. But that's exactly why we do it. We need it to be strong enough. We need it to be durable enough. From a project management standpoint, not only is it good to understand when and where we might use some of these, but it's also important to know that when you go to make a weld, the two ends that are being welded together are beveled. So beveled basically means cut on an angle so that the piece that you start to join is actually relatively thin compared to the overall wall thickness of the pipe. So what most people, I'm guessing, do not understand is that it takes many passes to close that weld and to make that joint. It's not a one pass thing. You don't just butt two pieces of pipe up together and put something on it. That's not how this works. You bevel it and you join it together. The more passes it takes, the more man hours it takes. So it's going to take more passes to close a Schedule 80 than it is to close a Schedule 40 joint. Does that make sense?
That makes complete sense. So when you said beveled, that really kicked it in for me. It's when you're joining these two pieces of pipe, the parts of the metal that actually touch each other are not the full thickness of the wall. And every time that welder is making a pass, they're creating the metal there that needs to be there for the joint to exist. They're adding material as they weld. And we all know that welding is adding material strategically in certain points, getting the metal hot enough to join it. But in this case, it's not just that you're filling in a little butt like you'd see in a structural joint where you've got one piece of metal going up to the next. It's that this pipe is so thick that you can't just do it that way. You have to build these layers this way. That's fascinating.
Well, it's the pressure. That's the difference between a fillet joint on a structural piece versus when you're putting pipe together, it's under pressure. So it has to be able to withstand the temperatures and the pressures over time and the expansion and the contraction over time, that it's a little bit different than the structural weld is. So how many passes are required? Depends. It depends on what the service is. It depends on the temperature, the pressure, what the specification tells you that kind of weld needs to be. If it has to pass an X-ray, for example, so I have a long-term client out in California that has a whole bunch of high temperature hot water. It's 350 degrees at 350 PSI, and it runs for miles around this campus. So it is so dangerous to work with a system like that. Those welds have to pass an X-ray. So you actually take an X-ray machine and you X-ray the weld to make sure there are no flaws anywhere in that weld before it passes inspection.
Wow. That's a very, very dangerous environment. 350 degrees at 350 PSI. I mean, think about the amount of pressure in your tire, in your car tire, and how much energy is there. I don't know if anybody's seen those videos online of like our tires exploding when people overinflate them. 350 PSI, that's lethal. That could really end a life. So I'm glad to hear that they're X-raying it. And that's an interesting note that you're making there too, that you could have Schedule 80 pipe over here that requires a certain amount of welding, and then Schedule 80 pipe over here that requires a different amount of welding, and that could result in another man-hour risk. If you don't read the specifications all the way through, if you don't understand the requirements, then you could be like, oh, with Schedule 80, everyone welds Schedule 80 the same way. Not really, according to this. That's great.
Yeah, it absolutely depends. So in a situation like that, because of the combination of temperature and pressure, it is absolutely lethal. If you make a mistake, that matters to the welder. The process that they have to use changes because it has to be able to hold up to that kind of temperature and pressure. They do multiple passes to essentially join the pipe, and then they put a cap on it. It's what's called a cap, and that's what we see on the outside is the cap. Okay, so the point of this all, again, is to make sure, not to make you a welding expert, but to make sure that you can ask more intelligent questions when this comes up on your project. So I feel like there's 1,000 looming questions out there that people are probably going, what about this or what about that? There's so many different applications and so many different circumstances. Your mechanical contractor, their weld experts are going to be the resident experts on this thing more than likely, or potentially your design engineer. So those are people that you can go to for more answers, or you can call me and maybe I can help you. Maybe I can just point you to the right person, because I am not a welder. I will say that over and over again. I am not a welder. I just have to know a lot about welding. Okay. Have you heard the old adage that size matters?
Oh, the innuendos with welding are off the charts.
Welders are a spicy bunch. So size does matter with pipe. So the larger the pipe diameter, the more difficult it is to weld and the more hours that are required to weld it. So back to your original comment of like, okay, well, this little tiny thing took 3 hours. And again, that was a conglomeration of lots of things that led up to completing that weld. And in that environment, there's all kinds of documentation and stuff as well that goes into that. But the bigger the pipe, the more weld inches there are, and the longer it's going to take to make each one of those passes and complete it all. So the more man hours it takes. So if you're saying, oh, I had that kind of pipe, it was 3-inch on my last job and it was fine. I know this is 6-inch, but it's not that much bigger. Yes, it is. Yes, it is. That's a lot more weld inches. So why this matters is because with this kind of welding, you're adding heat and metal to make the joint. People just say, well, just go faster. You can't just go faster, because if you go fast, you're going to get all different kinds of defects. One of the main ones that you're likely to get if you go too fast is porosity. It's an inclusion of gases into the weld that create a little bubble where the metal isn't and gas is, and that's not a good thing in welding. And that is a defect, and you'll have to cut it out and do it over again, or try to repair it. Potentially you could repair it. Going too slow results in a lot of puddling. Have you ever seen a picture of a really, really like messy, icky, looks like Frankenstein weld?
It looks like it dripped everywhere. It looks like it was just hot metal that was pouring out of something and cooled.
That's called puddling. That's also not a good thing. So puddling, besides looking really sloppy, you can actually overheat the pipe around the weld. That metal is the heat affected zone, and it can cause some defects in the heat affected zone, and you can actually cause pulling of the pipe and some physical defects that are going to also make your weld fail. When you have big pipe and you're starting to get into like 10-inch, 12-inch pipe, the bigger the pipe, the joint that you're working on will start to cool as you are moving around the pipe. Too much cooling too fast before you get back to that same spot is going to cause the pipe to deform and actually pull apart. For any pipes over 12-inch, you're probably going to need 2 welders welding at the same time on the same joint on opposite sides to keep that from happening. So if you've got a project with really big pipe, that's an important thing to know.
Even though we know from 3rd grade math that the circumference of a circle increases with the diameter of the circle linearly, the complexity of the weld increases much more precipitously than that. Welding a 3-inch pipe is a lot easier than a 6-inch pipe, and welding a 12-inch pipe is a lot harder than welding a 6-inch pipe. Good to know.
Yeah, it absolutely starts coming down to skill and experience. When you're talking about normal size things and typical 2.5-inch, 3-inch, 4-inch pipe, that stuff's pretty normal in the life of a mechanical welder. But you start getting much beyond that, and you really need your more experienced folks on there. Some of the younger folks may not have as much experience, and that speed in which they can do the weld starts to really, really matter. And the more experience you have, the better a judge you are of that. So next point is just like real estate. It's all about location, location, location. Where your welds happen matters a lot. These days, most contractors prefab as much as they possibly can in their fab shop, and then they send the rest of it to be done on the site. That's good for everybody. It's important to note that you're never, ever, ever going to get 100% in the fab shop. In fact, if you get 50% in the fab shop, you're doing really well. The reason for that is because you're limited to the shipping sizes, how much you can put on a truck and ship out to a site. Every joint that is open, you have to make out in the field somehow. 30-foot sections is about as long as you usually get And so you end up with maybe 50%, somewhere between 40 and 60%. In the fab shop. So shoot for 50%. It's a good number, but you're not going to get more than that, which means at least half of your welds are going to be in your higher risk environment, which is out in the field. Fab shops are great. They're controlled environments. They can achieve a really good result faster and cheaper with an asterisk. Here's my asterisk. Here's what I have found. And I've worked for mechanical contractors. I've worked for fab shops. When we started on this journey, this was the sales pitch, was that it's going to be cheaper if I do it for you in the fab shop. The reason that it's cheaper is it's a controlled environment. I can use automatic welding machines in fab shops. I can use less experienced and lower paid labor. I can have maybe a foreman with a bunch of apprentices, not as many journeymen, and so it brings the average labor rate down. These things are all still true. What I don't think the industry recognized right out of the gate is the cost to run a fab shop. The cost to run a fab shop, you need a lot of space. It's very high electrical use. It's very expensive rent or cost per square footage, your taxes and your overhead and all this kind of thing in your fab shop is quite high. And so I think in the beginning of fabrication, contractors were maybe charging a small amount per hour, like $10 an hour on their average fab shop labor rate to cover the fab shop expenses. I think it didn't take them very long to realize that that was inadequate. And so what we're starting to see now in the industry is we're starting to see contractors charging $40, $50, $60, $80 an hour on top of the fab shop labor rate.
As in for the field?
For the work that's done in the fab shop, you have one labor rate. So if they say, okay, we're going to do 50% of this work in the fab shop, that labor rate is, I'm just making numbers up, that labor rate is average is $45 an hour. Out in the field, your average labor rate is much higher. And so maybe that average labor rate is $75 an hour. So in theory, by diverting to the fab shop, if you're really truly only paying $45 an hour, it's cheaper for you, the owner. But if they're tagging on an additional $30, $40 an hour to the fab shop rate for the fab shop cost, I've actually had this happen on a job not very long ago, where when I dissected what was really going on, we were paying more to have it done in the fab shop than we were in the field.
So you got to be careful there about those markups people are placing. That's good to know.
I think that perhaps some contractors are stepping on that a little bit as a separate profit center. Just watch it. Just pay attention to it. Look at the labor rate and then look at what they're tagging on for the shop rate that goes on top of the hourly labor rate. And you have to add those two together to get your total labor rate in the shop. So make sure you are actually saving money by doing it in the fab shop. You're certainly reducing risk. Even if it works out to be even Steven dollars per hour, you're still mitigating risk in the shop compared to the field, but make sure you're not overpaying. So that's my asterisk for the day. Okay, the other part of location that matters is once you get out to the field, where are those field welds happening? I had a job one time that had a whole bunch of large underground carbon steel pipe. It's carbon steel pipe that was all welded. It was going to be insulated and buried. The problem that I had was that I had a foreman who was running the job, who was a newer foreman. I'm going to caution that if your job's got a lot of welding on it, make sure that your foreman is welding literate. I had a foreman that was not welding literate. And so when I would say, hey, let's look at the work that we've got left to do in this underground, how long is this going to take? He didn't understand that there's a huge difference between what happens in the fab shop and what happens in the field. So he was calling the fab shop manager saying, how long would it take to do this? And the fab shop guy only knows what the fab shop guy knows. He doesn't know where you're putting this pipe. He has no
That poor
idea.
foreman was getting bad data. That stinks. Ugh.
He was, and he didn't have enough knowledge about welding to understand that it mattered that it was in an 8-foot trench.
Didn't ask the right question. He said, hey, how long is it going to take to put in 50 feet of pipe? Oh, this long. He should have asked, how long is it going to take to put in 50 feet of pipe here, 8 feet underground in a trench? Oh, well, that's a totally different thing.
And the way you figure it out is you look at how many weld inches there are, what the metallic is, what the weld type is, and where it is. So many feet underground matters. Many feet in the air matters. If you have to make a field joint and it's way up there, 20 feet in the air, That also matters because now you have the mechanics of having to lift it. You have multiple people involved because it's got to be tacked into place. And this is kind of where we don't really get into those details, but it's got to be placed just so, it's got to be tacked, and then it can be welded. So there's a lot going on. And if you have to thread this through stuff that's existing, conduit and ductwork and all kinds of stuff, it just keeps getting more and more complicated. The other thing that matters is a thing that we call position welds. So position welds are kind of what they sound like, I think, anyway. You're getting a really, really awkward position and then you try and weld. That's what that is.
So get on a yoga pose on one leg, arm wrapped around this pipe, other one here. Yeah, where the position is the challenge.
And you can't see your torch because at some point, you're not going to be able to see it's up against a wall. You cannot get your head in there to physically see where you're going with that arc. So that presents its own set of problems. Mirrors can sometimes be used. It's an issue. It's a challenge. And this is, again, where more experience comes in, but also more.
You're going to need to budget that time. Don't be thinking that it's going to be as easy as welding something on the floor when it's up in the air around like that. I can't imagine trying to do something as difficult as welding, not being able to see the torch. The guys that can do that are magicians. That's just crazy.
There was a picture that a welder posted on LinkedIn, I don't know, earlier this year, and it was hilarious because exactly what you described. The guy's upside down in this funky pose on one leg trying to get this weld. What these people have to go through to get these welds done is really, it is nothing short of magic. And there's some out there that can just do it absolutely beautifully and flawlessly, and you would never know. So position welds are something else. And again, these are not things that as a general contractor, you're going to necessarily know where all these welds are going to take place. Your mechanical is going to take care of that for you, but they're questions you can ask. Have you accounted for this? If you find yourself questioning whether or not you have an overly optimistic estimation of how long these things are going to take, these are some questions that you can ask.
Yeah, you could go to your mechanical estimator who's providing you your bid during pre-construction and say, all right, how many position welds are in this job? And then ask that same question to the other guys, folks, non-gendered guys, and see who gives you what numbers. If one person says they're going to have 30, the next person says 32, and the last person says 2, and that person's cheaper, that could be why.
I would venture to say that in most estimators you talk to don't even know what a position weld is.
Well, that's another scary thing. If your estimator doesn't know from one company and does from the next, then you can be like, okay, now this is all coloring my opinion of this bid and the qualitative factor.
Who's probably going to know is your piping foreman or your piping superintendent or GF. They're the ones that are going to plan out the fabrication with the fab shop manager and figure out where they want those joints. And they're going to be having those things in mind. They're going to be laying out the whole thing and going, I don't want this joint near this corner, over in this corner in the wall. I want it to come out 10 feet where I can get to it, or 5 feet where I can get to it. If they're able to put mechanical joints like flanges and things like that, they're going to want to strategically place those in places where they can get to it and maybe avoid a weld joint if that's possible in that kind of system.
And if it's not possible to avoid it, then you just talk to your team about sequencing and say, okay, how can we make this as easy of a position weld as possible? Don't throw a bunch of ductwork in the poor guy's way. Those kinds of things.
Yeah, absolutely. This is sometimes why pipe people get a little bit cranky about other people going in before them, because this is the kind of thing they have to worry about. Other kinds of metallics can also be welded. Stainless steel piping and tubing can be welded. And I think this is a good place to explain the difference between pipe and tube, because you'll hear those words and maybe if you don't know the difference, you think they're interchangeable, but they actually aren't. So the difference between pipe and tube, we talked about wall thickness earlier. And that's really what we're talking about. Tubing is significantly thinner than pipe is. Pipe is always measured in OD, or outside diameter, where tubing is always measured in ID, or inside diameter. So if you're looking at a cut sheet or something on a drawing or something in a specification and it says ID or OD, that's what they're talking about. Inside diameter or outside diameter, that's how you'll know if it's pipe or tube. Copper is one of the very common materials that we use that is tubing, but we don't weld that. That's soldered or brazed, but it is tubing. So it's always measured as an ID versus an OD. So you'll get weird dimensions like 7/8, things like that. You'll get the funky fractions with the tubing diameters. Also want to interject a little fun fact here because I've been asked this on more than one occasion. Why can't we just weld galvanized pipe? Well, there's a reason that we try to avoid welding galvanized. It's not that you technically can't weld galvanized. It's that when you put heat on anything galvanized, whether it's a structural member or a piece of pipe or anything, it oxidizes the zinc. That's what galvanization is a zinc coating. And it oxidizes it and it creates toxic fumes that are very, very impactful to human health. So avoid welding galvanized when and wherever possible. If you do, make sure that you're taking proper precautions in protecting your respiratory system, your eyes, your mouth, your nose, all of that, because it can cause some very, very serious illnesses. I think there's a term for the illness and I can't think of it right now, but within a few hours of doing this, you will be very, very ill if you don't take proper precautions. Okay, there's also some exotic alloys that show up in the process. And an alloy, if you don't already know, is just a mix of different metals. Stainless steel is an alloy. Some of the exotics that we come across sometimes in pharmaceutical are Al6XN and Hastelloy. I believe those show up occasionally in microelectronics as well. Those are generally automatic welded. Those are tubing, automatic welded. This requires a very different setup involving specific weld heads for each size of tubing and specific knowledge for how to program the machine, balance all the gases, regulate the speed and the electrical current that goes into a good weld. One mistake I often see people make with automatic welding is they say, oh, it's automatic. All you have to do is push a button. Can't I hire the local apprentice to do that at $20 an hour instead of paying some experienced welder $80 an hour to do it or $100 an hour to do it? No, you really can't. And it's not as simple as it sounds. I mean, yes, that's how you activate the machine, but there's a lot that happens to get that machine to do the right weld. It's not smart. The machine only does what humans program it to do. Experience matters in all kinds of welding. Once on a project interview, this is one of my favorite stories. It was a contractor that was being interviewed for this really big project, and they did not have nearly enough welders on staff to man the job. And so I asked him, how are you going to address this problem? Where are you going to get the welders? And what they said was, oh, it's no problem. I'll just train up some people, and in 2 or 3 weeks, we'll have all the welders we need. Okay, well, I can't say that the person was wrong. You'll have a whole bunch of people running around with welding machines, but they're not going to know what they're doing. You do have to get certifications to weld, but just having the certification doesn't mean that you're the person that should be doing the work. So you could hire me to go do your welds. I could do it.
Doesn't mean the welds are going to be worth anything.
I am not the person you want doing your welds for any dollar.
Nor am I. We are bad welders. We are just people who are in awe of the good welders and know what it takes to make them successful.
For no amount of money do you want me doing your welds. So knowing how to do it and being skilled at it are not the same thing. Cranking out production at high level and getting passing welds on a regular basis matters a lot. It doesn't do you any good to make 100 welds if 90 of them fail. That is somebody that needs to be off your job in a big hurry. A failed weld should be an occasional thing, not a daily event. You need skilled, experienced welders. So how long does that take? Well, you bet there's 100 people out there that are going to probably have a different opinion, but I'm going to tell you what I've seen. Going from nothing, I don't know anything about welding, to being a decent production welder on carbon steel, couple years of constantly doing it. And this is one of the other problems that I see in the industry. Somebody will be presented to me that hasn't picked up a torch in 6, 8, 10, 12 months. That's not an experienced welder. That's somebody who hasn't picked up a torch in a long time. It's going to take them a while to get back into the groove. You want somebody who's continually welding as one of the main parts of their job. Going from being a good carbon steel welder to being a good automatic welder, another 1 to 2 years. It's not something you're going to learn overnight. The alloys are different. It's the difference between making a hand weld, which is a very specific art and science, to trying to get a machine to cooperate with you and programming it properly and getting the right balance of current and gases and all the other things that go into an automatic weld, it's a different skill.
I would use the metaphor to describe the difference here as like a surgeon who cuts with a scalpel, who goes to 6 years of medical school and interns and has so many hours and has so many successful surgeries, and you look at their statistics and you pick which surgeon you want to go with, to the kind of surgeon who uses one of those robots where it's got the thing that inflates your skin away from whatever they're trying to operate on. It comes in with the little things, and then you have to do the surgery using the robot. You still have to be really, really good at using that robot. And you don't want somebody who's only ever used a scalpel to just try the robot for the first time and do surgery on you, because it's the same risk to your life if it's something under high pressure or something containing some horrible chemical, which in a lot of cases it is. So don't sleep on how hard it is to automatic weld. It's not automatic at all. It's just that you're using a machine that takes a lot of learning to get used to.
They're just very different skills. And carbon steel welders, they're called dirty welders. And the automatic, they're called clean welders. And I have tons of love and respect for all of it, because a very, very good welder, regardless of the type, is worth their weight in gold. 100%. There are automatic welders out there that I can reliably get more than 20 welds a day, perfect welds a day out of them on a pharmaceutical site. That's a good number. That's a really good number. Reliably all day, every day in a single shift. There are carbon steel welders that out in the field in crazy positions, yoga welding out there, can produce a weld that is just as good and just as beautiful as a weld done in a fab shop. You can't tell the difference. That's awesome welding. It is really incredible to watch the people who have mastered this stuff. What you should be looking for in a good welder, if you're out there and you're listening to this and you're thinking, okay, well, how do I figure out whether somebody's a good welder or not? Well, the first thing you want is a welding certification. It's going to be required by your project specification anyway. So definitely ask for the welding certification. Make sure that you have a cert for each welder on the job and for each type of welding that welder's going to do. There's different kinds of welding. There's TIG, which is tungsten inert gas. There's MIG, which is metal inert gas. And there's SMAW, or shielded metal arc welding. So when and where those are appropriate, you can go ahead and watch my YouTube videos that explain a little bit more about that if you're interested. But you also need to make sure that when those welding procedures and individual certs are submitted to you, that you check and make sure that there's continuity there. So they're called continuity welding certs. The expiration dates on them need to be within 6 months of right now when you're reviewing it. So I've had this happen to me before on jobs where somebody gave me a welding cert for an individual welder, and it was 10 years old.
Oof. It's like having an expired passport and going out of the country. Not a good choice.
Well, I don't know what that means. I mean, I didn't automatically assume that it means the person hadn't picked up a welding torch in 10 years, but how do I know that? What is supposed to happen is they're supposed to be issued continuity certs by whoever's managing their certifications within their own company every 6 months or so, maybe once a year. If it was a year, I probably would have let it go. But years and years and years old like that, come on, help me out. Just tell me this guy's been welding for, on and off at least for an extended period of time. We want to make sure that we're getting the right people in the right spots. And I know that I keep saying guy. I think because most of the welders that I know are men, but I actually know some really kick-you-know-what female welders. Just saying. I don't mean this at all in a gender-specific way, because there are some baddies out there that are really, really good welders. In fact, one of our friends, her and her husband were both welders, and she taught at the local forever.
Wow.
She taught welding. There's definitely a lot of lady baddies out there that can strike an arc. I'm so amazed by their skill. Okay, what you definitely want to avoid is somebody who got their certification last week and is welding on your job this week.
It's like you don't want to have your teenage son or daughter driving around with their friend who just got their license and 4 of their closest friends. It's not a good recipe.
That used to happen all the time when I was a teenager. I think they've changed the laws in a lot of states now. You can't do that anymore. There's a reason for that. Let's not all crash together. Welding is just a mean combination of art and science, and you definitely get what you pay for. A good welder is 100% worth their weight in gold, and they're very, very proud of the work that they do. They love to show you their welds when they're complete. I had this welder on my job. I worked with him for many years. Then I worked with his son, who was also a welder for many years. His name was Gus. He was one of the best and most talented welders I've ever worked with in my whole career. He would do these crazy welds and then say, "Come here, Miss D, I want to show you." And I'd get down in the trench and he'd say, "Guess which one is mine?" One of them was a shop weld and one of them was the crazy yoga position field weld that he just did. I couldn't tell. It was perfect. And his stuff never leaked. It was great. So definitely don't be afraid to pay for a good welder. It's well worth it. It's truly a craft. That's all I can say.
And whenever you find craft people who are proud of their craft, whether it be welding or some other discipline, encourage them. When there's somebody like this on your site who's so proud of their work, they want to show you. Make that job site their favorite job site. Pay attention to what they're trying to tell you. Give them the kudos that they're deserving, because everyone else is going to be like, oh, these people get it. If the guy who's really, really proud of his stuff can go say, hey, she really understands, that's going to be the kind of thing that stands you in good stead. The rooms that you are not in, people will talk well of you in those rooms. And the craftspeople are people you want speaking well of you, because there will be times that you need to call on them and say, hey, I know this sucks. This is coming down from the top. We've just got to beat this date. And if you are someone who deserves their trust, who understands them, who listens to them, you're more likely to get a better outcome when you have that conversation.
So this information and probably a few things we didn't hit on, there's a series of videos on yspe.co's website where we talk about some of these and some other items around welding. If you're a welding expert, give us a ring. We'd love to hear from you. I'd love to hear what your experiences are. If there's some deeper conversations we want to get into about welding, it is tremendously important to your project that your durations are estimated correctly, that your budgets are estimated correctly around this welding. It can, if you have a project that has a ton of welds on it, that project that you mentioned, Brad, that we were on, that thing had thousands and thousands of welds on it. On a job like that, very, very important that you get it right. It's an extreme risk to your project budget and schedule. So stay safe out there, and we'll talk to you next time.
Thanks for listening.
Watch us on YouTube at YellowstoneProfessionalEd.co. Don't forget to like, share, and follow us, Apple, Spotify, everywhere you listen to your podcasts. You can email us with questions, comments, and suggestions at heydee@managementunderconstruction.com. That's HEYDEE to get me or Brad at managementunderconstruction.com.